Hello, I welcome you all in this lecture related with the subject failure analysis and prevention, and we will be starting the new topic which is failure analysis of the formed products. So, in the farming we know that farming can be of the bulk metals through the processes like rolling, forging, extrusion, or it can be related with the sheet metal where the shearing or the plastic deformation or their combinations are used for manufacturing the different products. Whenever the material is subjected to the plastic deformation either in localized manner or in the entire zone, the lot of material properties are affected, and which in turn affects the material performance during the service. Therefore, it is important to understand the fundamental aspects related with the metal forming, which will be affecting the material performance, material characteristics, and eventually their performance during the service. So, in this presentation, we will be talking about the importance of the subject like metal forming and its effect on the performance of the product which is being made by the metal forming processes, and then basics of the metal forming like what are the general approaches, under what conditions the metal forming is undertaken. Accordingly, we define it like hot forming or cold forming, then how these affect the structure and mechanical properties of the material and which eventually affect the performance of the product during the service. In additionally, we will also be talking about the common issues which are encountered in the form products. So, this chapter basically this presentation basically will give you the idea of the different aspects which should be explored and investigated whenever the failure of the formed product takes place during the service. So, we know that the forming of the metal primarily involves the plastic deformation. Forming of the bulk metals involves the plastic deformation. So, this plastic deformation whenever it takes place, you see, especially under the low temperature conditions, it leads to the generation of the lot of dislocations, and because of the generation of dislocations, it leads to the strain hardening. So, strain hardening in turn affects the mechanical properties. This is one of the aspects, and that is why what we say that metal forming affects the properties, but not just the mechanical properties, lot of other properties like corrosion resistance, resistance to the fatigue, and the behavior of the material under the low temperature condition or even under high temperature conditions, all those are affected. In addition to the effect of the metal forming on the properties of the components which is being fabricated or manufactured, so it also affects the subsequent stages of manufacturing, because the manufacturing through the forming approaches will not be done in just one step. It requires multiple steps to change the stock material into the final product, and whenever the product is deformed, its properties get affected, properties get modified. So, this continuous change in properties many times in unfavorable manner adversely affects the ease of manufacturing or ease of forming in the later stages. Okay. And that is why it is a metal forming affects the manufacturing in the later stages also. Okay. So, if we have the idea of like how the metal forming will be affecting the mechanical properties, we can easily assess what will be its the real performance during the service. And if we get idea about that, then the factor of safety which is to be used, that can be reduced. Reduced factor of safety means reduced weight. So, there are two aspects, like in all those applications, in all those products where the weight is important, for like say in automotive, in a spacecrafts, wherever the weight is important for the proper functioning and efficient functioning of the system, the formed products which are offering the higher yield strength, higher hardness, in turn helping to reduce the section thicknesses, and also ability to understand the properties of the products which are being made by the forming process. If we have precisely about the idea of these properties, and that can also help in reducing the use of the appropriate factor of safety. Use of the appropriate factor of safety means not using unnecessary very high factor of safety like 2, 3, but even 1.5 factor of safety may also be good enough. So, if we have greater idea, greater understanding about the properties of the products being formed, then we will be able to choose the factor of safety more appropriately. So, and that in turn, apart from the enhanced mechanical performance of the product and the material, that will also be helping to reduce the weight of the product. Okay. So, therefore, what we say, the product performance is affected by the manufacturing processes. Now, again it will depend upon, because there is a very wide range of the manufacturing process including casting, welding, machining and forming. So, again in the forming, the extent of effect depends upon whether the forming is being done under the cold condition or hot condition. So, it has been found that the properties in the two conditions are affected in different ways. So, we will be talking in detail about these aspects. Okay. So, understanding and the knowledge of the work hardening or even the softening under the high temperature, or the phase transformation if it is taking place under the either low temperature forming conditions means cold forming, or under the hot forming conditions. So, understanding about these will help in better prediction of the strength, and so lower the factor of safety and the weight of the product. So, that is why it is important to understand the way by which forming is going to affect the structure, properties and so the performance of the product during the service. If you have better idea of work hardening, the softening if any taking place, or the transformation, phase transformations which are occurring during this the deformation, okay, which in turn will be affecting the mechanical properties, especially the yield strength, hardness, ductile to brittle transition temperature and lot of many other characteristics are affected. So, if we see in the forming, so if the metal is subjected to cold forming, then what we will see, that cold forming primarily affects the work hardening, means increasing the strength and hardness of the material, but this happens at the cost of toughness, means resistance to the impact loading and ability to get elongated, that is the ductility. So, ductility and toughness both are compromised. In addition to this, one more change is observed, that is the increase of the ductile to brittle transition temperature. So, these are the three undesirable effects observed in the mechanically deformed products, especially under the low temperature conditions. So, the cold forming does these leads to these undesirable effects, but there are apart from this these change in mechanical properties, the another change which is observed is in terms of the development of the residual stresses, like these residual stresses also induced in the localized deformed products. So, most of the time the residual stress developed is the compressive. So, when the compressive residual stresses develop, they enhance the tensile strength, means the tensile properties and the fatigue strength in terms of under the tensile load conditions, because whenever the residual stresses are present, they of the compressive type are present, then they will be acting against the externally applied tensile stresses, whether these are static or these are fluctuating type. Okay. So, they help in actually residual compressive stresses help in reducing the severity of externally applied tensile stresses, and therefore, they help in increasing the tensile strength and the fatigue strength, especially under the fatigue load conditions. So, because of these two important changes which will be occurring under the cold forming conditions in the metal, the static strength means yield strength, ultimate strength, these are enhanced. Okay. The fatigue resistance, fatigue strength is also enhanced, means ability to take up the fluctuating load for a given number of cycle, that will be enhanced. Impact resistance is enhanced if there is no major change in the ductility because of the increased yield strength, but this happens very rarely, and but certainly it can happen in case of the hot forming, when the refined and grain refined means refined equexed grain structure is achieved. Corrosion behavior is compromised basically because of this work hardening thing, because the work hardening is never of the uniform across this section. It is more near the surface layers and less in the cores. And apart from this, the material changes which are occurring in the product or in the metal, that can also affect the resistance to the corrosion. The damage tolerance is something which is extremely important in the formed products, especially those which are subjected to the cold forming. The reason is materials, the fatigue materials, the fracture toughness, or the toughness and the fracture toughness, uh, if these are being compromised, then this compromise will be adversely affecting the tolerance to the defect size that can be tolerated by the component. Tolerance to the defect size is reduced if the toughness and the fracture toughness are compromised, especially under the cold worked conditions, or metal subjected to the cold working. Okay. So, if we see that if the fracture toughness K is reduced, then sigma pi C, C is the defect size, sigma is the applied stress, and the K is the fracture toughness in terms of the stress intensity factor. So, this Kc is a critical stress intensity factor, which is a material property. These get, if these get compromised, then for a given applied stress, our the crack size gets reduced due to the reduction in the Kc. Likewise, for a given tolerable crack size, for a given crack size, if the Kc is reduced, then the maximum stress that can be applied will also be reduced. So, that is what we can, from this we can get idea of like the damage tolerance is affected when the material is subjected to the cold forming. Okay. So, we know that in the forming broadly can be grouped in the two categories. One is the bulk metal forming involving the plastic deformation, which can occur under the high temperature conditions or under the low temperature conditions. So, and accordingly we define it as a hot forming or cold forming. Okay. And the common processes in the bulk metal forming category are rolling, forging, extrusion and drying. While in case of the sheet metal forming, like we have, it can involve shearing, which is basically cutting, and the deformation also. So, sheet metal forming processes which will be involving the shearing, like the blanking, punching, notching, niveling, shaving, parting off. All in all these cases, the metal is sheared off to achieve the desired size and shape of the component, or to get the desired geometrical feature in the product. While the stretch forming, embossing and coining, these simply involve the plastic deformation, and this plastic deformation will be increasing the strength, hardness and making the sheet metals more stiff. Okay. So, this is about like the broad approaches which are used in the sheet metal forming. So, if we talk of the cold metal forming, so cold metal forming, the when the plastic deformation of the metal is undertaken in controlled condition below the recrystallization temperature, then we call it as a cold forming. And if the cold forming is done, then the work hardening is one of the phenomena which dominates. Okay. Similarly, localized plastic deformation of near surface layers, this leads to the development of residual compressive stress. So, work hardening is taking place means yield strength and increase of the hardness is taking place, but certainly at the cost of our yield ductility and toughness. Since the metals at a low temperature, they are of the high yield strength and the high yield strength and low ductility, this makes the deformation process little difficult, and that is why it requires greater force and the power consumption to facilitate the cold forming. So, if the metals are having reasonably good ductility and the low yield strength, then it will be easier to do that, easier to cold form that. But the metals which are having very high yield strength, very low ductility, then probably the heating is the better option in order to reduce the yield strength and enhance the ductility, so that it can be deformed plastically. Since the cold forming is done under the room temperature condition usually, so there is no major oxidation, there is no major dimensional change due to the heating and cooling kind of thing. Therefore, the good surface finish is extremely good, largely due to the absence of the oxidation, and the tolerance, like in Hot forming, when material is heated, there is a dimensional change, there is expansion, and then material is subjected to the deformation, and after the deformation again it is cooled, which will be leading to the shrinkage. So, this heating linked expansion and cooling linked contraction of the metal in hot forming makes the dimensional control very difficult, and that is why when the cold forming is done, tolerance is reasonably good, tolerance is much better, control over the tolerance is much better as compared to the hot forming. The hardening and embrittlement, many metals when they gain the hardness and the yield strength, but they lose their toughness and ductility. So, that is what we can say, the metals, the damage tolerance is reduced, metal becomes more brittle due to the loss of the toughness. Additionally, it also leads to the increase of the ductile to brittle transition temperature. So, if the metals are responding in different ways which is not expected in the service, then it will lead to the failure. So, in order to establish the failure, we need to keep all those the possibilities open, and we need to investigate and establish the things accordingly what would have led to the failure. The grain structure is elongated, means in the certain directions initially the metal may have the equaxed grain, but when it is subjected to the plastic deformation, grains may get elongated and deformed in a particular direction, and when the metals grains get oriented in particular direction, it responds in much better way in the direction in which the grains are elongated, and that is why we find much improved performance in that direction as compared to perpendicular to that. So, this brings the anisotropy, means the variation in the performance and properties of the material in the different directions. In addition to this, we frequently come across the banded structure, and the banded structure means it will be like there will be bands of few hard and the soft phases. So, whenever these bands are present, this promotes the notch effect, and the notch effect leads to the increased the crack nucleation tendency, and once the crack nucleates, it starts propagating. So, this is the another effect of the forming in the metal, but which may be happening even at a high temperature. When the forming is warm forming is one when the forming is undertaken above the room temperature, but below the recrystallization temperature, just for the softening purpose, but not heating above the recrystallization temperature. On the other hand, so the hot warm forming gives the results in between that of the cold forming and hot forming. Okay. Now, if we see the hot forming is a plastic deformation which is carried out above the recrystallization temperature, so that metal gets softened, yield strength is reduced and makes the material more ductile, and these things reduces the work hardening tendency, like material may be strained, but the change in the at a high temperature, the strain hardening is almost absent in the hot working condition, while otherwise it may continuously with the plastic deformation, metal gains more strength, so it requires further more higher level of stresses to cause further plastic deformation. That is the kind of scene which will be absent in. So, the work hardening tendency or the strain hardening exponent is 0. There is no hardening when the hot forming is carried out. So, no or negligible work hardening. Okay. And when the metals due to the heating, yield strength is reduced and percentage ductility is enhanced. So, this makes the deformation easier, and that is why using the less force and less power consumption, material can be subjected to the plastic deformation. But since the metal is exposed to the high temperature, so it will be interacting with the atmospheric gases, and that will be leading to the oxidation, nitrite formation at the surface due to the interaction of the metals with the oxygen, nitrogen and the surrounding environmental things which may interact with the metal at a high temperature to form their reaction products, and that in turn reduces the surface finish. Okay. And as I have explained, in the hot forming the metal is to be heated first. So, when we heat, there is increase in dimension of the product. Okay. And with the increased dimension, it will be subjected to the deformation. So, when it is subject to the deformation, obviously it will be taking certain shape. Thereafter, it will be cooled down to the room temperature. So, cooling again will be leading to the shrinkage. Okay. This shrinkage makes the dimensional control of the hot form products difficult. Okay. So, the expansion and the contraction due to the heating and cooling during the hot forming makes the dimensional control difficult, and that is why the control over the tolerance is poor in case of the hot form product. Usually hot forming results in a very refined and equexed grain structure. So, this is expected to offer the good combination of the strength, ductility and toughness. So, this is what schematically has been shown here, like the process classification: cold forming, warm forming, hot forming. So, this is the demarcation line. Above the recrystallization temperature we have hot forming, and below the recrystallization temperature we can have warm or cold forming. So, when it is done under the ambient condition or below that, it is cold, otherwise in between the ambient condition and the recrystallization temperature it is the warm forming. We know that increasing the temperature reduces the yield strength, increases the ductility. So, for forming, the favorable condition for forming is the lower yield strength and the higher ductility. Okay, greater percentage elongation. If metal is showing these two combinations, then the forming will be easier, but most of the time metals do not show this kind of the behavior, and if it is the case, then heating facilitates in realizing these properties. So, heating will be in reducing the yield strength and increasing the ductility, and that is why hot forming makes the forming approach little easier. But all metals do not respond in the same way. Say for work hardening of the different metals is not same. For same plastic deformation, the increase in the strength and yield strength and hardness will be different, and that is what primarily governed by the stacking fault energy associated with that particular metal. Okay. So, the metals showing the low stacking fault energy, they show metals having the low stacking fault energy, they show greater work hardening and strain hardening tendency, and those which show high stacking fault energy, they do not show much of the work hardening tendency. Okay. So, this is the case of like aluminum, magnesium, while the low stacking fault energy metals like stainless steel, even the mild steels, they show reasonably good work hardening tendency. So, depending upon the metal which is being subjected to the plastic deformation at a room temperature, the work hardening will be different. Few metals work harden very rapidly as compared to others. Okay. This is the another aspect which we can say as a thermal softening. So, heating, increasing the temperature of the metal will be reducing the yield strength and increasing the ductility, but the trend of reduction in yield strength with the temperature will be different for different metals because of the varying resistance to the thermal softening. Few metals show greater resistance to the thermal softening like stainless steel or high nickel steel, carbon steels and nickel and copper alloys. So, if you see for the same rise in temperature, the drop is negligible for stainless, drop is not much in case of the stainless steels and nickel steels, but it is significant in case of the carbon steel and alloy steels. Okay. And this is the typical trend what is being shown here, which indicates that in at low temperature metals show greater yield strength, ultimate strength and elongation, but for certain metals even there is a drop in the maximum ductility, maximum deformation that can be achieved. So, it depends like on the metal also, otherwise the trend may be like this with the change of the variation in temperature and the you can say sorry, the strain here and the stress here, and for the high temperature, for medium temperature and for the low temperature. Low temperature lesser elongation, greater strength. If we increase the temperature, yield strength is reduced, metal tends to elongate more, and coupled with the reduction in the strength of the metal, and further higher temperature, lower strength and longer the deformation prior to the fracture. Okay. So, depends for the different metals, different combinations can different trend of the variation in the stress strain curves can be obtained. Okay. So, this is what happens when the plastic strain is induced under the low temperature conditions, metals hardness increases, metals strength increases. Okay. On the other hand, when the deformation is undertaken at a high temperature, then the increase is very marginal. Okay. This is attributed to the negligible or almost zero work hardening exponent of the material. So, if we try to see the effect of the forming temperature on the ease of forming and power, then the power requirement decreases with the temperature, and ease of forming increases with the temperatures. So, this is what how the forming temperature affects the ease of forming or the power requirement. Similarly, the forming temperature, if we see, the dimensional accuracy is compromised, while and the surface roughness increases, means these are surface finish is compromised in that way. So, the product characteristics variation as a function of the forming temperature, because of the this expansion of the metal during the heating and contraction during the cooling makes the dimensional control very difficult, and that is why dimensional accuracy decreases with the increase of the forming temperature. Now, there are multiple factors associated with the forming which affects the performance and properties of the product, like the deformation speed. So, if we try to deform the metal at a higher speed, then it tends to behave like more brittle material. Okay. That is what we can see here. If the two metals are subjected to the deformation at different rates, say low rate of the loading or high rate of the loading, okay, then we get the trend of this kind. Low rate of loading means it allows the lesser ultimate strength and but the greater elongation. On the other hand, high rate of loading allows the lesser elongation prior to fracture but higher load. So, this is what we can say, that the speed at which the load is applied, speed at which the metal is subjected to the deformation, that will be affecting the material behavior, material properties. Similarly, the temperature at which it is being done, that will be affecting the yield strength and the ductility, and the work hardening behavior different for different metals. The different behavior is observed, like for one metal the behavior may be like this, for another metal behavior may be like this, for third metal behavior may be like this. So, what you can say, SS, mild steel and aluminum, say they are showing the behavior like this. So, for same plastic deformation, the change in the stress requirement, that is significantly different. So, this variation is attributed to the work hardening tendency of the different material. Sometimes a few metals show the transformation, means the phase change. So, the metals when subjected to the plastic deformation, they experience the deformation assisted transformation. Okay. Deformation assisted phase transformation, and if takes place, it is possible like the material in the beginning was soft and that it has become hard and strong after the work hardening. So, it is a possible like certain high manganese steel and head field steel, they show this kind of behavior, where when the material is subjected to the plastic deformation, their austenite converts into the martensite, and that helps in increasing the strength and hardness. So, the deformation of the material during the forming processes can be undertaken in different ways, like say use of pressure or the impact. When the pressure is used, roughness is low, when the impact is used, roughness is high. Similarly, anisotropy, the property variation, when the impact is used, then the anisotropic tendency is more as compared to the case when the pressure is used, and cracking tendency is more when the impact is used as compared to that of the pressure. So, now here I will summarize this lecture. In this lecture, basically I have talked about the various the fundamentals associated with the forming and the way by which the forming affects the material characteristics, which in turn affects the performance of the product during the service. Thank you for your attention.